Okay, example 1. Find a sequence of transformation which takes the graph y equals to square root x to the graph y equals to square root 5x minus 2. So that's the original equation. That's the new one. So y dash equals to 5x dash minus 2. So square root on both sides is all good. I don't need to change anything. So y just equals to y dash. There's no change for y values. But x will equals to 5x dash subtract 2. And I want to talk about the transformation applied. So I need to know what's the relationship between the new one and the old one. So the new x needs to be the subject to see what has been applied to the old x. So x dash will equals to 1 on 5 x plus 2. Okay, 1 on 5 x plus 2. Okay, so if we have this, we can do two ways. If I can make x dash equals to 1 on 5x plus 2 over 5. Okay, I can write that into two forms. Okay, if you have your equation in this way, you will say there's a translation first. Okay, the order of translation, dilation, and reflection does matter. That will be the same as your calculation order. For this one, you calculate plus 2 first. Then you need to talk about translation first and then followed by a dilation. So it's a translation of 2 units to the right. And then dilate by a factor of 1/5 from the y-axis. Okay, it's changing the x value, so it's from the y-axis. It will be the same as your calculation order. So plus first is the translation first, and then the dilation. Okay, but if you talk about this one, okay, this one you open the bracket, dilation first, and then the translation. Okay, you will multiply the 1/5 with x first, so that's a dilation by a factor of 1 on 5 from y-axis. Then translate 2 on 5th unit to the right. Okay, so you can see if you dilate first and then translate, the units will be different. Okay, so this one translate for 2 units and then dilation by 1/5. This one will be dilate by 1/5 and translate only by 2 on 5 units. Okay, so that will be different. Okay, so this example show you that the order is really important. If I suggest, I would say do this method. Okay, do this one, because dilation, DRT order, dilation, reflection, and translation. Better to talk about that in this order. So it's easier for the teacher who's going to mark it. Okay, so and it's really clear. There's no some teacher will say, they think is 2 and 1/5. Even though you write the correct answer, still can be a mistake, can mark you wrong. So follow the DRT order will be nice and easy for all of us. Okay, so expand all the bracket, dilation, reflection, and translation. Follow this order to talk about that. And the next one, example 2, find the sequence of transformation, take from that to the graph of that. Okay, so this is the original one, that's the new one. Okay, so we will have y 1 on 2, y minus 3 equals to square root 4 minus x. I will only leave square root on the right hand side. And for the next one is negative y dash minus 6 equals to square root x dash. Okay, so x dash will equals to 4 minus x. So you will say that is minus x plus 4. Okay, it's already in x dash to be the subject. And you will have minus y dash subtract 6 equals to 1 on 2, y minus 3 on 2. Okay, and you will negative both sides. Have that. And you will plus the 6 y dash equals to minus that y plus 6, so it's 12 on 2, so it's 15 on 2. Okay, you have 15 on 2. So let's talk about that in DRT order. So you have dilation by a factor of a half from x-axis, reflect in the x-axis because it's all changing the y value, and then translate 4 units to the right and 15 over 2 units up. Okay, so dilation a half from the x-axis is changing y, reflected in the x-axis is talking about the negative, and then translate 4 units to the right is talking about the, there's a reflection in the y as well. Okay, reflect in the x-axis and y-axis because it's a negative x. So reflect in x-axis and reflect in the y-axis, and then translate 4 units to the right and 50 on 2 units to up. Okay? Questions? All good now? Okay, next one. Next one, like, it's a special one. So I have a lot to talk about for the next one. So the next one, you got y equals to 3x squared minus 4x plus 1. And you have the new one is y dash equals to 4x dash squared plus 4x dash. Okay. What we can do to this one? How we can equalize both sides? What form we need this quadratic to be? Turning point, okay? Because I have 2x in both equations, it's not going to work. I can only have 1x, and that can work. So turning point will give you only 1x in each equation. So we need to find the completing square for that. So take the 3, so x squared minus 2x. I'll leave the plus 1 outside. So I have y 3 x squared minus 2x plus 1 and minus 1 and plus 1 outside. So y equals to 3. You have the brackets still, and those 3 can be factorized. It's x minus 1 squared subtract by 1 and plus 1 outside. So y equals to 3 x minus 1 squared subtract 3 plus 1 is subtract 2. Okay, subtract 2. Okay, that's this one. And let's have a look at the second one. Second one, we have y dash equals to, take the 4 out, is x dash squared plus x dash. Okay, you will plus a half squared and subtract a half squared. And that will be 4x dash plus a half, the whole thing squared, subtract a quarter, but it's in the bracket. So it's 4x dash plus a half squared subtract by 1. Okay, hopefully there's no problem for completing square. Okay, and this is still not the form I want yet. So what I'll do is y plus 2 over 3 equals to x minus 1 squared. And this one is y dash plus 1 over 4 equals to x dash plus a half squared. So I will have y plus 2 over 3 equals to y dash plus 1 over 4. Okay, equalize both sides. So we will have, okay, let's do this. That's 3y dash plus 3 equals to 4y plus 8. Cross multiply both sides. And 3y dash equals to 4y plus 5. And divide the 3, so it's 4 on 3, y plus 5 on 3. Okay, 4 on 3y plus 5 on 3. And then for the x side, the x is x minus 1 equals to x dash plus a half. Okay, you don't need to include the square because it's both things square. So I just have x minus 1 equals x dash plus a half. So x dash equals to x subtract by 3 over 2. Okay, so there will be dilation by a factor of 4 on 3 from the x-axis. Okay, 4 on 3, and then no reflection is translate 3 over 2 units to the left and 5 over 3 units to the right. Yep. Doesn't matter. Okay, you can talk about x first or y first. That doesn't really matter. But just follow the DRT order. Okay. Any questions so far? Like for this question? Okay, what's the dilation applied to? The dilation is applied to the y values. It's dilation from the x-axis. If I change my question, I want to ask that the dilation will happen for the x value, which means the dilation will be from the x-axis. What's the factor? Okay, translation doesn't matter. You still can translate from y or from x, but the dilation will only happen to the x value. Okay, so it will be dilation from the y-x-axis. Okay, so you need to change the x. So what you can do to this one? Okay, there's no dilation from the x-axis now. This one happened from x-axis. As I showed you yesterday for the square root question, you can dilate from x, you can dilate from y, you can dilate from both x and y. The factor will be different. Okay, this one, the dilation only happened from the x-axis. What will happen if the dilation only happened from the y-axis? What you can do to this question? Have a think about this. There is one question in the mock paper or real VCAT paper, I can't remember. Is asking the same question like this. Okay, what's the dilation factor from the x-axis? What's the dilation factor from the y-axis? Will give you the same graph. Okay, there's a question like that. And it's for a quadratic question. Okay, you are not going to times with y. Okay, there's no coefficient in front of y, which means there must be coefficient in front of x. So I need to make the constant into x, okay, not combine with the y value. So what I can do is, let's go back to this one. I will write something here. Okay, I'll write below here. So from this step, what I will make is, I'll use a green color, y plus 2 equals to what? Equals to square root 3 squared. X minus 1 squared. Okay, I can make different base but with same power. And y plus 2 will equals to square root 3x minus square root 3. And that whole thing squared. Okay, I'm not dividing the 3 to that side. I make that into the bracket. Okay, that's not a coefficient anymore. That's like the whole model now. Okay, that thing squared. Okay. So the other side, I can do the same thing. So from the previous step, y dash, from that step, y dash plus 1 will equals to 2 squared, x dash plus a half squared. So y dash plus 1 equals to 2x dash plus 1 squared. Okay, I put the 2 into the equation. Now when I get to equalize both sides, y dash will equals to y plus 1, and then x2 x dash plus 1 equals to root 3x, subtract root 3, so 2x dash will equals root 3x, subtract that plus 1, okay, subtract root x, subtract root 3, subtract 1, and x dash will equals root 3 over 2x, subtract root 3 plus 1, the whole thing over 2. Okay, so what I can do to this one? So that's a dilation by a factor of root 3 over 2 from y-axis. Translate root 3 plus 1 over 2 units to the left. And then translate 1 unit up. Okay, the factor all changed. Okay, all the factors has been changed, but like they will result in the same graph. Okay, they will result in the same graph. Any question about this? Questions? Okay, have a think about this question. It's a pretty good question. I pretty like this one because it can give you like the thinking, like always remember the dilation can happen in X or can happen in Y by different factors. Okay. Okay, let's have a look at next one. I use a lot of spots of this one. Okay, that's still example 3. Okay, have a look at example 4. Find a sequence of transformation which takes the graph y equals to fx to the graph of y equals to 3f bracket 1 minus x minus 2. So for this question, the f is actually the easiest thing to deal with because the f is the model. Okay, you just leave f bracket on the right hand side, everything else to the other side. So y equals to fx and y dash plus 2 over 3 will equals to f1 minus x dash. Okay, now you have 1 minus x dash equals to x. So x minus x dash equals to x subtract by 1. X dash equals to minus x plus 1. And then for the y side, y dash plus 2 over 3 equals to y. Y dash equals to 3y subtract 2. Okay. The first one talk about dilation. Dilation by a factor of 3 from x-axis. Okay, reflection then. Reflect in the y-axis is changing the x values of in the y-axis. Translate 1 unit to the right and 2 units down. Okay, BRT order. CRT order. Any questions? Okay. If there's no questions, let's talk about matrix. Okay, let me have a think. Should I talk about matrix first? Well, okay, let's talk about matrix first. Okay, using matrix with transformation. Okay, using matrix for transformation. So there's a particular way, like, okay, as I said, like moving one unit to the right, you will write x dash equals to x plus 1. Okay, for matrix, there's a particular way of writing it. When you see the matrix itself, you will know what kind of transformation has been applied. Okay, what kind of transformation has been applied. Okay, it will be the same as giving you the word description. For dilation from the y-axis, okay, from the y-axis, you will have, it's changing the x value. So at the x position, you write a factor n there. That's a dilation from the y-axis by like factor n. And you keep 1 for the y position and have 0, 0 on the other side. That's a fixed notation. Okay, you're not going to change it. So when they say dilation by a factor of n from the y-axis, you will give this matrix out. And dilate from the x-axis, you will put the y value become a because it's changing the y value. And dilate from both axes, the x will be changed and the y will be changed. Okay, so that's like fixed notation. Okay, when they say like that, you will write this matrix out. So transformation matrix for reflection. Okay, if you reflect in y, you minus the x position. If you reflect in x, you minus the y position. If you reflect in both sides, you minus both parts. But there are two new things. Okay, there are two new things. The first one is reflect in the line y equals to x. Okay, if you reflect in the line y equals to x, your new x will become the original y, and your new y will become the original x. So you will have 0, 0 for the this diagonal, and you will have 1 and 1. They change positions, okay? Which means they change positions. So that's a reflection in the line y equals to x. Okay, give you an example. So that's the inverse function. Okay, if I have a line here, so that point is 4 and 1, and then that one will become 1 and 4. That is not. Okay, we have 1 and 4 here. So it's changing the position for x and y values. So it will change the 0 and 1 place. Okay, the next one is reflecting the line y equals to negative x. Okay, y equals to negative x. Okay, it's for this line. So if you reflect in that position, you will have point here. Okay, so it will become -1 and -4. So the new x will become the negative of the original y, and the new y will become the negative of the original x. You can see the reflection here. So you will still change the position for 0 and 1s, and now you will negative the 1 as well, because it's negative of the original x and negative of the original y. So that's a fixed notation. Remember it. Okay, remember it. And the last one will be translation. So the translation just basically add a 2 times 1 matrix. Okay, a 2 times 1 matrix. So row 2, column 1. Okay, a 2 times 1 matrix. have a look at this one. Find the image of the point 2, 3 and a reflection in the x-axis. Okay, so and the x-axis is changing the y value. So part A will be, okay, it's changing the y value, so x will remain the same, y will become -1, and you want to apply this transformation to this point. So is this transition matrix times the xy values, okay? Is the transition matrix, that's the transition matrix, that's the point itself. You times them together, that will give you the new point. So remember last week we talked about matrix calculation. So you have row, and column. So you have, that's row 2 times 2, that's 2 times 1. Those two are the same, so you can times them. You will result in a 2 times 1 matrix. So it's a 2 times 1 matrix. So it's 2 and minus 3. Okay, it's 2 and minus 3. 1 times 2 plus 0 times 3, and 0 times 2 plus -1 times 3. So it's a 2 and -3. That's how you times the matrix. Part B is a dilation of vector k from the y-x-axis. Okay, it's a dilation of vector k from the y-x-axis. It's changing the x value. So you have k 0, 0, and not going to do anything with the y value. And you have the point 2, 3. Okay, row, column. 2 times k plus 0 times 3, you have 2k. 0 times 2 plus 1 times 3 give you 3. So it's 2k, 3. Okay, you will write out the points directly without having this matrix, but like this is something tell you how the matrix works. Okay, tells you how the matrix works. Okay, example 2. Example 2, this is like quite special type. So consider a linear transformation T maps 1, 3 to -2, -3, and another point 2, 4 to the point -3 and -11. Find the image for -1 and 1. So this transition matrix T, I don't know, like it's a combination of a lot of things. I don't know what is it. So I will give A, B, C, D. Because it's a 2-dimension transformation, it's like x and y values, so the transition matrix always be 2 times 2 matrix. If it's 3 times 3, you cannot times them together, so it must be a 2 times 2 matrix. So you will have A, B, C, D. Let's say that's the transition matrix. Okay, there can be a lot of things happening, but I don't know what exactly they are. So first one, what give you is A, B, C, D times 1, 3 gives you -2 and -3. The next one is A, B, C, D times 2, 4 and gives you -3 and -11. So what you will have is A plus 3B gives you -2. C plus 3D gives you -3. Okay, row, column. And this side will be row, column. 2A plus 4B gives you -3. 2C plus 4D give you -11. Okay, so you will use this pair and this pair to solve that simultaneously. Let's do this one. So let's make equation 1, equation 2, equation 3, and equation 4. Equation 1 times 2 gives you 2A plus 6B equals to -4. Say that's number 5. Okay, let's use number 5 to subtract number 4. 6B minus 4B is 2B, -4 minus -3 is +3, will be -1, -4 subtract -3 is -1, and B will be -0.5. So A will be minus 2, subtract 3 times negative a half. A will be negative a half. Okay, so I have A value, B value here. And the next thing I want to know is C value and D value. So equation number 3 times 2 will be 2C plus 6D gives you negative 6. Okay, number 6. Number 6 subtract number 4. 2C, 6 minus 4 is 2D. Minus 6 minus negative 11 is plus 11, so give you a 5. D will be 5 over 2. So C will equals to minus 3, subtract 3 times 5 over 2. C will be minus 6 over 2, subtract 15 over 2. C will be minus 21 over 2. So the transition matrix will be A value is negative a half, B value is negative a half. So C value is negative a half or 21 over 2, and the D value is 5 over 2. Okay, I'll use that to times negative 1 and 1 because I want to find the image of that point. Okay, what I will do here is I don't want to take all the negative halves into calculation. I will take negative a half out as common factor, and I will have 1, 21, and negative 5 as the new function, and that is negative 1 and 1. And that will give you negative a half. Okay, what's the result? So row and column. So 1 times negative 1 plus 1 times 1, which is 0, and negative 21 plus negative 12, okay, is negative 21 plus negative 5, minus 5 is minus 26. Okay, it's minus 26. That will be 0 and 13. So the image will be 0 and 13. Hopefully there's no calculation mistakes. Okay, if you find any place which is wrong, please tell me. Okay, there's a lot of calculation here. Okay. Okay, I will wait till you finished. I want to show you another 2 examples. I want to finish transformation a little bit earlier than like what the schedule is, because I see the polynomial only give you half weeks to talk about polynomials, so there's basically 1 lesson to talk about polynomials. I want to spend like 2 or 3 lessons on it, like to talk about something more. So I need to save some time from transformations and give some time to polynomials. Okay. Okay, example 3. Okay, let me finish examples 3 and 4, and I think next lesson I will spend 1 more lesson to finish that. Okay, find the image of the points 2 and negative 3 and the reflection in the x-axis followed by a dilation factor k from the y-axis. Okay, so what I want to do is write out the matrix first. So what is the matrix? A reflection in the x-axis, so it's changing the y value by a factor of k. So you have k values here, and it's a reflection in the x-axis changing the y value is a -1. Okay, reflection in the x-axis, and followed by a dilation factor k from the y-axis, which is changing the x values. You will have that. Okay, you will have that. And the point is 2, -3 must be transition matrix at the front and then the points at the back. If you swap the order, it cannot be times together. Okay, if you swap the order, it cannot be times together. So that will give you 2 times k, which is 2k. 0 times that is 0, so 0 times 2 is 0, -1 times -3, which is 3. So it's 2k and 3. Okay, the points will become 2k and 3. Okay, example 4. Express the composite of transformation of dilation of a factor k from the y-axis. Let's do that one by one, okay? A dilation of factor k from the y-axis is changing the x value. So k 0, 0, 1. Followed by a translation defined by the matrix C equals A plus B. So you will times the xy, the old xy, to that matrix, and then you will plus that matrix by AB. And then mapping a point xy to the point of x dash and y dash. Okay, so that will equals to x dash and y dash. Okay, does that make sense? Okay, so first the old original points will times this transition matrix, and you plus that the translation matrix, that will equals to x dash and y dash. So what's the question is asking for? Find x and y in terms of x dash and y dash. So you want to xy to be the subject. Okay, you want xy to be the subject. So you're trying to solve for xy. Okay, you're trying to solve for xy. I have 2 ways to do this. Okay, so let's do the first way. The first thing I want to do is calculate that. Okay, 0 and that you have kx and you have y. Okay, times the first 2, and you have a, b equals to x dash and y dash. So you have kx plus a equals to x dash and y plus b equals to y dash. So x equals to 1 over k x dash subtract by a, and y equals to y dash subtract by b. Okay, so you have this method to do it. Calculate, okay? Calculate that, and then change that in the last step. The second way is solving this as matrix. Okay, solving this as matrix. So 0, 0, 1, xy will equals to x dash subtract a and y dash subtract b. Xy will equals to, you cannot divide by matrix, so you can times the inverse of that. You have this. Okay, so AD minus BC, you will have 1 over K. AD is K times 1 minus BC, which is 0, so it's 1 over K. And you will swap the order of this main diagonal, and you put negative sign. The negative 0 is still 0. Okay, swap the order, and that's still 0. You will have x dash minus a, y dash minus b. So times them, that's the row, that's the column. So you will have xy equals to 1 over k. Okay, that is k bracket x dash minus a and y dash minus b. Wait, have I swapped? I haven't done the inverse. Wait, I have subtract that and I will inverse that. So AD. So that's the main diagonal. So 1 over k and 0 and 0. So times that together. Okay, that's the correct version. So let's times that in, that's k, that's 0, and that's 1. And then x dash minus a and y dash minus b. Row, column. So xy will be 1 over k times x dash minus a and y dash minus b. Okay, that's correct. So x will equals to 1 over k, x dash minus a, and y equals to y dash subtract by b. Okay, that's correct. Okay, swap those two. And then 0 minus both 0, so still 0. Okay, and you have 1 over k. Okay, the books is showing this method. Okay, the books using the right hand side method, but I think it's too long. Like this one is much easier. Okay, just calculate, follow the order to calculate that, and finally equalize both sides and make x dash and y dash to be the subject. I always use this method. I will show you more examples like according to this type, so you can see this is an easier method. Okay, so next lesson, I'll do the rest of it. Okay, I'll do the rest of it.